The UK Government have set a target for the UK to reduce its emissions by 80% by 2050. They've also set a target for aviation, and we're committed to delivering on it.
Aviation is responsible for 2 to 3% of global man-made emissions and 6% in the UK. We have a collective responsibility to reduce that.
Tackling emissions is not just an environmental imperative, it's an economic one as well. Reducing fuel burn has a positive impact on the bottom line for a business.
The government has made it clear that the industry's growth will be capped to achieve its CO2 target, so it's in all our interest to work together to do all that we can to meet and exceed it.
The UK industry is leading the world in our collective approach to pioneer new techniques and procedures which will improve our environmental performance.
With air travel forecast to resume long-term growth, the environmental footprint that goes with this presents the aviation industry with a stretching challenge. How to manage noise and air quality, and above all, to reduce emissions as air traffic increases.
Sustainable Aviation was established in 2005, and it brings together the four corners of the aviation industry: airlines, airport, the airframe and engine manufacturers, and our ATC company, NATS. We come together behind one common vision, and that is a more sustainable future for aviation.
Air navigation service providers have a key role to play by improving airspace design and optimising air traffic management so that these deliver fuel savings and reductions in emissions.
At NATS, we've made environmental responsibility one of our core values, and we're the first ANSP to set ourselves an environmental target, which is to reduce ATM CO2 emissions by an average of 10% per flight by 2020.
Next generation technology and airspace design will give controllers exciting new tools and procedures to help achieve the perfect flight, minimising the environmental impact. New airframe and engine technologies are improving the efficiency of aircraft all the time. Helping them achieve their perfect flight means ATC, the airports and the airlines working closely. So what is this perfect flight? It's one where the aircraft ascends through a continuous climb with constant acceleration. As it enters the cruise phase, the aircraft attains higher speeds and greater range as the fuel is used to gain distance and height as its mass falls. The descent follows a smooth, continuous profile using the minimum idle descent angle, landing without the need for airborne holding. The goal is an overall profile which increases fuel efficiency and reduces CO2 emissions.
It is clear that optimising an aircraft's flight profile has a direct effect on reducing emissions. Simply put, fuel saving equals cost saving equals environment saving.
There are many good reasons why an aircraft may not fly a fuel-optimal or perfect flight profile. Maintaining safe separation, weather conditions, capacity, tactical and operational demands of airspace boundaries can all compromise fuel efficiency. These won't all go away. However, by understanding and targeting the areas of flight that create inefficiency, the industry can deliver better flight planning, better altitude and speed profiles, and shorter, more direct routes. NATS has developed a clear picture of the environmental footprint of its operations. Almost 58% of CO2 emissions come from aircraft flying in domestic airspace, 37% from aircraft within the North Atlantic area, and 5% come from aircraft operating on the ground at the 15 UK airports where NATS provides the ATC service. Overall, aircraft operating under NATS control in 2009 emitted 22.4 million tonnes of CO2. Even before an aircraft takes off, important decisions are made which affect its environmental performance. Filing an individual flight plan tailored to the aircraft type, weight and traffic conditions expected at the time of travel is essential to help ATC offer the airline operators preferred route and altitude. Individually tailored flight plans are also essential to enable airlines to take full advantage of available conditional routes to reduce track mileage and save fuel and emissions. The 1.5 million tonnes of CO2 emitted at the airports where NATS provides a control service is produced primarily from taxiing. Takeoff and ground holding together contribute the remaining 25% of emissions, and airlines, airports and ATC are already working together to find ways of cutting them.
At Heathrow, we're investing in state-of-the-art technology such as fixed electrical ground power and preconditioned air to help airlines reduce their reliance on auxiliary power units that will then draw power from the ground electricity, which is 10 times more efficient and less polluting.
Taxiing is also under the spotlight. A 747 closing down 2 engines on taxi-in can save 120 kilograms of fuel, worth around £60. Multiplied by many hundreds of flights each day, this alone can save thousands of tonnes of fuel and emissions every week. Through another innovation to trial concepts for arrivals management as part of CESAR, NATS has been coordinating with airlines and air traffic control at other airports to hold aircraft on stand when there are known delays at the destination airport. Holding on the ground rather than in the air can save up to 1/4 of a tonne of CO2 per minute. The most fuel-intensive part of a flight is the climb, when an aircraft is at its heaviest. In order to ensure safe separation, aircraft are often required to fly in a series of steps, separated by periods of level flight, which isn't environmentally efficient. The most fuel-efficient profile is a smooth, continuous, ascending trajectory, unimpeded by conflicting traffic to cruising altitude.
Long-haul aircraft could save nearly 1.5 tonnes of fuel and 4.5 tonnes of carbon dioxide per departure. British Airways has nearly 700 departures a day, so we're really keen to work with NATS to deliver these environmental benefits.
Multiply the BA benefit across all airlines and the fuel and emissions savings could be vast. Continuous climb departures are already part of the early design principles driving a major airspace review for the London area. The height, speed and route of an aircraft in cruise can markedly affect its fuel efficiency and CO2 emissions. Reducing the amount of track miles an aircraft flies and enabling it to fly at its optimum cruise altitude will minimise its environmental impact.
In our planning and in our day-to-day operations, NATS is working hard to simplify the choices for airlines by providing more direct routes to reduce their track miles flown and to provide better speed profiles to enable more efficient flight and to accommodate different types of aircraft.
In the future, emissions trading will effectively increase the cost of fuel, giving airlines greater incentive to choose the most fuel-efficient profile. Continuous descent approach is already well embedded in UK operations, but more work is needed to enable true tailored arrivals from the top of descent. The aim is to enable aircraft to descend smoothly without using too much thrust, achieving an optimum trajectory from cruise to ground in a smooth, continuous descent. That's assuming the aircraft doesn't have to hold. Airborne holding accounts for 2% of all CO2 in NATS-controlled airspace. 3/4 of these emissions are generated by aircraft arriving at Heathrow, where over half of all inbound traffic has to wait to land. Whilst holding is an effective method of managing inbound flow and maintaining safe separation, airborne holding results in extra fuel burn and emissions. Arrivals management and tools such as AMAN will start to make a difference, and innovative trials are underway with airlines slowing down en route in order to reduce time in the hold. The perfect flight is now in the industry's sights, and just as the UK pioneered the use of CDA, so it is on course to pioneer a through-flight experience that will significantly cut fuel burn and emissions. Better flight planning and speed control can deliver environmental and fuel efficiencies now, but uptake varies depending on the individual airline, pilot and controller. Best practice needs to become second nature. Better technologies and procedures within the next 5 years will help improve trajectories and reduce airborne holding. Within 10 years, airspace change will mean we can expect better climb and descent profiles.
There's no doubt that we can make major fuel savings if we operate closer to each aircraft type's optimum profile. That makes good business sense and good environmental sense.
Doesn't matter who you are or where you are, you have a critical part to play in delivering the environmental performance improvement within aviation that I believe is possible.
It is clear that environmental issues will play an increasing role in shaping the future of aviation. Looking wider into Europe and beyond, cooperation with other industry partners will help achieve industry change to support environmental goals and government targets. Organisations such as ICAO, IATA, CANSO, CESAR and Sustainable Aviation all have clear environmental agendas and are actively engaging with stakeholders. The perfect flight may be an aspiration, but many elements are deliverable today. By continuing to innovate and adopt, the UK industry can meet both government and public expectations.
The UK's target for aviation to reduce our emissions to 2005 levels by 2050 is a challenge, but we know at Sustainable Aviation that we can do it through new technology, through new fuels and through working together to improve the efficiency of our operations.